With Nagaro's diverse range of resilience engineering services, you can build robust and reliable systems and ensure business continuity. Our tailored solutions ensure that your brand has the unbeatable advantage of staying at the top, even during unforeseen events.
All right. Hey, everybody. Welcome to day 2 of Chaos Carnival 2023. This is Sanda, your host for the session, and Raj Das, your co-host. And I'm a senior software engineer at Harness and a maintainer at Litmus Chaos. And I am super stoked to introduce our speaker, Ruturaj Kadikar, who is an SRE at InfraCloud Technologies. He will be talking about testing resiliency within and beyond Kubernetes. So without any further delay, let's get started. Over to you, Ruturaj.
Okay, cool. Let me share my screen.
Yeah.
So let me know once it is visible. Is it visible?
It's visible.
Yeah, sure. Hello, all. I'm Ruturaj. So I am SRE at InfraCloud, and basically my journey from in InfraCloud is from Dev to DevOps to SRE. And currently, I'm solving challenges around production grade EKS and observability, uh, resiliency, DR, like that. So I'm pretty enthusiast, and we'll be talking today on uh, testing resiliency within and beyond Kubernetes. So basically, we always think like resiliency or chaos inducing like pod crashes and everything, but more or less the system in most of the organization is beyond Kubernetes. So you have dependent services and other things. So how to deal with that, we'll be looking today. So with that, we will start. So first, you have been going through chaos, resiliency, reliability from yesterday. But once again, to get all in sync and reiterate once again, as you can see in simpler terms. So the meme suggests everything. So the person pushing the other person is actually the chaos. This person standing up again is like resiliency. He's resilient enough to stand back again, and repeatedly if it is happening and repeatedly he is able to stand again, that is the we can call it as reliability. Speaking into classical terms, we can state that chaos is nothing but a state of great disorder or something, like the person is pushing the other person, and the anomalies that are occurring into the system and which may lead to downtime or outages in your system. Example, pod crashes in Kubernetes and all. Resiliency, on the other hand, is maintaining the original state, okay, or the steady state, we can call it. Steady state is nothing but your conventional state that is running fine into the production system. So any issue happens, the ability of your system to get back to the steady state is nothing but is defined by resiliency. Okay, and with such failures or issues happening into your system at let's say periodic times or frequently, and still you are able to system is able to survive all this and get back to the steady state, we can call it as a reliability system. So so reliability is nothing but the ability to produce the similar results with the same conditions again and again. So with that context, we'll move forward and we'll see. Uh, okay, why should I test the resiliency in first hand? Okay, so firstly, you need to identify the behavior of your entire system. So whenever any failure or fault happens, like what is the behavior? For every such failures or whatever the failures occurring in your system, if you know the behavior, then you know the what remediation you have to do. So for that, we have to execute different kinds of failures or chaos or faults into your system, so that we know the system better. Now, failures can be categorized into three parts. First is system capabilities. Failure can happen due to system capabilities like saturation, like your network getting saturated or storage is full or something like that. Secondly, the anomalies which you might be not knowing, and suddenly that happens, like whenever you're upgrading any system and there is a version mismatch, there are deprecated APIs or something, and due to that there is some chaos happening and there is a downtime. So second category is anomalies, and third is manual errors or accidental deletions or accidental misconfigurations. So all these type of failures may happen into your system, and we have to be ready enough to remediate all those, or to identify. The first place is identification. If what failure happens, what we have to do. So for that, we need to test resiliency. Secondly, once you know what kind of failures are happening with your uh, basic research and everything, you can minimize the number of failures that are happening. At least those failures which are repeatedly happening, you can minimize them. And further, you can be ready for the anomalies which you don't know. Third is whenever such errors happen into your system, the time to debug is very crucial when you have to minimize the downtime. Okay, so if you know what kind of failures are happening into your system, let's say I crash a pod. Okay, due to that, what the cascading effect is happening into my system. So pod may get up again because it is resilient enough, but during that microseconds or second of time, what is the cascading effect over all the entire system? That we need to figure it out, and we need to correlate. And that's why if you have such experiments or failures happening into your system deliberately, then you can reduce the time to debug. And thirdly, we all do this to maintain the uptime of our system and to maintain the given SLAs and SLOs. Okay. Now, what are the failure? As we might already be knowing, but we'll go through that again. We can induce chaos in Kubernetes, where we can categorize the failure or fault domains. So first, you need to identify what are the failure, where the system can fail actually, or where you can induce the fault in your system. So accordingly, we can categorize them into number of failure domains in Kubernetes. One is network. You can induce latency between two services. You can induce packet loss, jitter. You can create a black hole. You can block one particular IP, block one particular service, or block one particular port, and see what is the effect. So we categorize that into network. Next is pods. Depending upon pod crashes, there might be init container. So if the init process is not completed and it is stuck, the pod doesn't come up. Okay. Or similarly, if there are any pre-scripts or post scripts running into your system, and that processes may get stuck, what how your system will respond, that you need to figure it out. If there are any sidecars, and that sidecars are consuming more resources, that might hamper your pods and may crash your system. So similarly, you have to identify what are the failure domains. If the pod is coming up but it is not able to pull the images from the image registries, so these kind of faults we can identify into pods category. Then we have processes. You have kubelet process running on the node, container runtimes like container D, Docker. So just deliberately try to kill those processes, see what happens on your system, whether it is recoverable or there is any cascading effect or some other services is having effect of this particular killing of the service. So basically, you have to categorize the processes also. Next, we get node termination, node saturation, like saturation on storage. Let's say the pod is able to schedule on that particular node, but it doesn't provide, that node doesn't provide you any excess memory that the pod requires. In that case, the pod is running, but you're not able to the pod is not able to survive properly. So you have to test for saturations wherever it is possible. Next is load patterns. You can test with spiky loads or busty loads or any other patterns which you see in your system, and see how the system responds to that particular load patterns, and whether it can recover such load patterns. Lastly, we can have like misconfigurations into environment variables or dependent services. You can categorize accordingly. So all these are failure domains. You have to place this or identify your failure domains into your ecosystem. Okay, we have generalized this accordingly, but it may vary from use case to use case. Now we have seen the failure domains in Kubernetes. Is that it? No. Uh, our entire ecosystem is consists of Kubernetes plus dependent system. Majorly, it can be databases, messaging services, cloud infra. Okay. So, how you will identify the failure domains in these particular systems? So to do that, we have like for databases, we can again have a network category. Like we can have partitioning. Let's say you have a 3 node or 5 node cluster. There is a master slave architecture, and you're taking out or partitioning where there is a partition into your cluster. You're taking out master. What happens? So whether you need to check that there is some delay between master election, and that is hampering your system. If you take out that particular master, whether there is any split brain happening into your cluster, and what is the effect of that, and how it is able to recover from that particular thing. So once you know these issues, then you can have a remediation on top of that, and accordingly you can resolve those issues. So partitioning is there, then time travel or NTP synchronization is not there. Suppose it you don't have the synchronization between these databases nodes, then what is the effect of that? You can measure this particular as a failure domain in your system. Apart from that, there might be latency and packet loss, and you can see how your read and write cycles are happening because of this latency and packet loss. So these kind of we can categorize a network. In other categories, you have let's say you have access issues. Your service is not able to access that particular database. There is no termination if the node is killed. One of the node of the cluster is killed. Again, load, you can test the load patterns on your databases or messaging services. At what sometimes it may happen that on particular let's say up to 5x or 10x load, your system is able to operate properly, but after 10x or 15x, there might be some issues due to load patterns. So you need to identify on that. And lastly, you can categorize. Let's say you're taking replicas of your databases, but you need to test whether in any failure of your cluster, whether your replicas are able to restore properly or not, or whether you are taking the backup of your databases and that backup is restoring properly or not. So this kind of failure domains you can identify, and this can be extended to the messaging, like a 3 node Kafka cluster or any messaging queues. You can test for active standby. So depending upon if the active is taken out, whether the standby is taking place as a primary or not, or that delay is causing what issues and all. So this type of things you can identify. Next, on the cloud, we can come. So basically, you can go for instant termination restarts. Uh, you can go for like misconfigurations into your security group knackles, which may cause holes into your systems. So you need to test that. Load balancer, you can remove target AZ subnets and see what happens. Like you might be having the HA enable into your system, but is that HA really providing you HA? You need to test that. So you can take out this subnets from the target groups, and you can check that. You can check for IAM permissions. So it also falls into the misconfigurations categories. And lastly, you can have AZ downtime simulation. So we have seen some instances where AZs are gone down, and in that particular scenario, how your entire ecosystem is behaving properly or not. So let's say easy down simulation is nothing but all the nodes in your EKS are taken down in that particular AZ. Similarly, the nodes of the databases and other services are taken down when that particular AZ is down. So these kind of failures you can act on beyond Kubernetes. Now coming to the execution part, how we proceeded. So we started from FIS. We dig into something, but again at that particular time there were no gradation like resiliency scoring and all. So we explored other tools like Litmus, Gremlin, Chaos Monkey, but we chose Litmus, and the reasons for that are firstly, it was open source, easily available. We were able to try and do a POC around it, whether it is fitting our use case or not. Second, you can have centralized or distributed approach. So again, when we say like we have to execute chaos or induce faults into cloud, so we have multiple accounts. So many organizations are having multiple accounts. So you have to carry out the chaos into multiple accounts. So with this centralized or distributed approach, you can categorize how you have to place your chaos or litmus, and you have to execute the chaos accordingly. Secondly, it is flexible enough to run via CLI, via UI, and we were able to have some serial or parallel workflows around it, scenarios for the chaos, and flexible enough to have a granular like weightage for particular experiments, like for pods and all. I know that pods comes up quickly. I may have let's say less points for that particular chaos experiments than for the black hole or something. So you can actually reduce or increase the points according to your use case. And lastly, what we found was it has a integration with AWS SSM documents. So just to highlight what is AWS SSM documents is nothing but AWS resource that creates some documents in the system manager, so that according to what document or the script, you can call it as a shell script, the system managers runs that particular shell script on the AWS resources. So whatever you want to do into your cloud, you can write a script around that in AWS as SSM, AWS SSM document, and you can run that script so that you can achieve the action what you want. So with these reasons, we proceeded with Litmus, and we had further. So this is what we actually used Litmus. So Litmus can be is having the like a Litmus core or control plane and agents which actually execute the chaos scenarios for you. So we placed the core into our central account from where we have to induce Litmus. So Litmus agents are again categorized as self agent and external agent. So on the central account, if you want to execute any chaos, we can use self agents, and on the spoke accounts, if you want to execute chaos, you can use external agents. So with this architecture, we are able to induce chaos into multiple accounts. Now how it happens is, you as we have seen earlier, you write a SSM document, you put it as a config map onto your system. Litmus agent takes that config map, puts it into your uploads it into your cloud, and triggers the run command around that documentation, and that whatever the chaos you write, whatever the experience we have seen earlier, like pod crashes, or you can use the inbuilt experiments too, but for the operations which are there in the cloud, you can write the documents around that, and you can induce the chaos accordingly. So this is how we proceeded with our use case. Next, so once you have like entire, like you identified what failure domains you have to identify the failure domains, you identify what experiments you have to carry out, you created a POC around like creating or inducing the chaos. Next, what you can do. So we recommend that you should have a resiliency framework wherein you define your steady state first, then you do a hypothesis as mentioned by AWS systems. So you do your hypothesis. Let's say if you have a chaos happening into your system, how your system will behave. Do some hypothesis, execute chaos, verify whether your hypothesis and the current state is matching or not. If there is any diff, identify the reasons and create a report. Work on those diffs and improve your posture of resiliency, and then again do the same procedure. So have a particular resiliency framework around this. uh, you can have a resiliency scoring. We have seen how resiliency scores are being used in the past, like from yesterday. You can have game days. So let's say game days is for educating all the DevOps teams. Randomly create chaos and see how the team is responding or identifying the issues happening into your systems. You can have periodic resiliency checks again. You can include resiliency in the CD pipelines. We have seen in the previous talk how you can do that. And ultimately, from whatever the diffs and issues you are getting from running chaos experiments, see whether everything is in place. Like for every issue what you are facing, do you have alert for that? Are you able to see from logs, metrics and traces whether it is visible or not? So the motive here is to reduce the time to debug, again what we have seen in the earlier slides. So ultimately, this will improve, not just improve your resiliency and thereby reliability of your system, but also the observability of your entire system. Uh, okay, this might be like enough talk. Let's see it in action. So for a demo, what we have seen is we will be seeing how we can write SSM doc, a sample SSM doc, and how we can trigger that from Litmus. That we will be seeing in the demo. Let me run this. So okay, now this is how the console of Litmus Chaos looks like, and we have seen the Chaos agents like Litmus agent. So this is a self agent which is running in the current system. So that is why it is called self agent, and it is active. Uh, you can use Chaos Hub for internal Kubernetes. You can use experiments which are there in the Chaos Hub. So these are all the templates you can use over there. Then we'll see how we can create a template for SSM. Okay, so getting the template, you need to run the chaos actually. So we'll schedule a chaos. We have selected the agent where we have to run the chaos. We'll go with the experiments from the chaos hub since we want to get the template. You can put a name over here, and next you can select. As of now, I want SSM for my templating. I have to run the custom SSM. I will take the SSM template over here that induce chaos on particular instance ID. You can tune your experiments. You can add probes and everything according to your use case. Here you can mention the instance ID where you want to execute the chaos or something like that, and then you can give the points for your particular experiment. Now, again, as you have mentioned, periodic checks and everything, you can have this in the recurring schedule. If you click next, you will get YAML uh, in this. So in this YAML, you can see that we have what name we have given, and all the things like instance ID and everything is mentioned in the template. So what we will do is we will take this template and we will customize this for our particular use case. Now, as you can see, we need to have a config map, as we have seen earlier. So this is the config map. I've given EKS SSM test as a name, and for demo purposes, it is just I'm inducing a sleep of 2 minutes and just echoing like this is chaos through SSM. So you can, whatever the chaos you want into your cloud, you can put it as a SSM script over there, and you can run it. And that particular config map we have taken into the template. So you can see I have applied that particular CM into the kubectl. Now we will see the template. Now for template as a config map, we have already passed that particular config map into this. We have provided the instance ID what we want. Below you can see document path as the SSM or the config map which we have provided. Okay, then you can pass cloud secret. If you have OIDC enabled, you can use service account. As this is a demo, I'm just using secrets over here, and that secret is passed as a credential file. So this customization I have done onto my template, and now we will apply this template and see what happens. So again, we have selected. Now we'll import the YAML file. I can change the name so that it is identified easily. Yeah, the code is fine, and we can start the chaos. So this is the experiment running. We can see now the chaos. So you can see the experiment is started, and installing chaos experiment is nothing but it is getting the infra ready for you. So Litmus has custom resources, various custom resources. Out of that, one is Chaos Engine. Chaos Engine, nothing but whatever the chaos scenario you have put, it executes. It helps to execute that. So we'll see whether the Chaos Engine is up or not. So it is not there yet. So now the chaos is actually it is going to the chaos stage, and we can see the Chaos Engine is up. So you can see the chaos engine. There is another custom resource to check whether our chaos is executed properly or not. That is chaos result. We'll also check that. You can see the relevant pods that are that the chaos engine wants, that are being spawned, and they are running. So you can see the chaos result is waiting for that particular chaos to be executed. Can describe this chaos result and check whether what is the result of that. So as we see, it is awaited. So your execution is still in process. As we know that we have induced a sleep of 2 minutes, just to showcase that how the command runs. So if you come to the systems manager and you go to run command to see whether your command is being executed or not. So as you can see, the command execution is in progress, and the document name is EKS SSM test, which we have provided earlier, as we have seen in the config map. So currently it is in the sleep, so it is not executed. So now you can see that the command execution is success, and we can see that whatever the we have put into the script, that is being executed or not. So yeah, you can see here that it is echoing this is chaos through SSM. I'll take it further a bit. So if you describe it again, the chaos result, it will depending upon the template timing and all, it may vary. So now you see the stage is cleared, and it is on the stage of reverting the chaos again. So if you see now, the result is pass, and since it is at the revert chaos, we'll see whether the document uh, is removed or not. So as you can see here, the document with the name, it does not exist. So whatever the object was created, it is being reverted back. So this is how you can write your SSM documents, and you can execute the chaos on the whatever the components which are residing outside of your Kubernetes. Uh, so on a end note, we have like one quote which is very famous: "EU sweats more in training, bleeds less in the battle." So just to modify a bit, I have made like the system that undergoes more chaos fails less in production. So that's me when I induce chaos. And yeah, thank you. So,
Thanks, Ruturaj. That was amazing. Love to see Litmus to be executed for non-Kubernetes experiment, and I hope our attendees also got a lot of information from this talk. So I'll just quickly take up the question. So we already passed the time, right?
yeah.
We have one question from Vivek. I'll just put it in the screen. Did you guys have any difficulty in installing the agent on different kind of architecture like Kubernetes, EC2, or Lambda?
No, as far as your connectivity within different accounts is proper, there is not any major issues with that. Just the agent should able to connect with the server properly. And one thing for this is you have to specify node selectors, because if you are taking down the AZ, make sure your litmus pods are not in that particular AZ, or else your experiment will get stuck.
Yeah, makes sense. Okay, thank you, Vivek. So the next question is from John. So I'll just put it in the screen. So what are the integration you have used alongside with Litmus for a better chaos engineering experience?
So we have as we have mentioned, right, we are generating reporting. So with the APIs which are available with Litmus, we are in-house providing generating how we can have that particular reporting in place. We are creating pipelines around it, so that particular I can see, yeah, that only integrations we have done. So observability, reporting, and CI/CD. these three categories.
Okay. Thanks, John, for asking this question. So, I think sadly, due to our time constraint, we have to close this session. But don't worry, you can post your questions in our Slack channel, and we'll surely answer to your questions. So, yeah, thank you. Thank you, Rituraj, for this talk. I hope everyone
Thank you.
got a lot of